So I'm going to look at mapping in this tutorial, looking a little bit about how you can represent the same formula or the same mathematical equation of some sort in a bunch of different contexts using Revit, and actually in this case I'm using Vasari. What I have here is I have a couple of sine waves. These are both the same 3-point loaded adaptive component family, and you can do all sorts of things with this family, like you can move the waveform along. This is called the translation of the curve, so that the waveform starts at different points. You can change the amplitude of it through various means, and this is the same instance of the family. You can change what the range is, so you're going to see the same curve, but it's just going to continue farther or shorter depending on what I do with this. So if I drag this guy out, it's going to take a little while, but you're going to see that the curve is now going to extend into a farther range. And basically all the aspects of a sine wave are represented here and are manipulatable, whether it's through canvas controls, or it also has a number of properties here where you can do things like you can adjust the frequency. So if I increase this number, you see the waveform get much more gentle. So if I do this, change it to 0.5, you'll see basically twice as gradual here, like that. Or if I change it to 1, you'll just see one complete arc, like that. So I'm just going to open this thing up for edit, and we're going to take a look. And so here is my 3-point adaptive component, which creates these curves. What I've got is I have a bunch of incremented lines. So going back to what I covered a couple videos ago with increment, where you've got a loaded family and you change one integer value of it and it steps through a series of calculations. That's what each one of these lines is. And then, so you can select all of these. And these are all the same thing. If I hide them all, you can see that all we've got left is we've got this spline by points, which connects the top of each one of these lines. Now if I look at each one of these loaded families in turn, we can see we've got this family, which looks a lot like what we were doing in another video too, which there are links to in the blog. So basically what I've got is I've got a point, and that point is driven by an x and a y coordinate that moves it up and down. If we go back into here, you can see that I've got a sine formula that creates a y offset parameter. If I look at this point right here, it has an offset and is hooked up to y. And y in turn is driven by what looks like a fairly complicated formula, but basically it's your basic sine formula with variables put in place for what its amplitude is, that is how far up and down it goes, the frequency, how many times it goes up and down based on a certain distance, and translation, which is how far away from zero that sine wave starts. And each one of those variables is an instance parameter. And what I want to point out right here, first of all, is that it also has step. And step number and point number are very important for how this thing works. So step and point combine to make what the x position is. So I've got my y position, which is a straight sine formula, and the x position is a step that is in feet and a point number, which is an integer value. To show how this works, I'm going to put another point out here in the environment. Whoops. Right there. And I'm going to do a dimension from that line to here. I'm going to make myself a new parameter. And this is going to be just another controller. So I'm going to add a parameter. I'm going to call it control. And it's going to be an instance parameter. And if I go back in here, I'll have my control with 2 T's, whatever. And just to illustrate what's going on here, I'm going to set point number to be equal to control in a certain way. I'm going to go call it control, and I'm going to do control divided by 10. So this is an integer value, so this is basically going to take my 24 and it's going to round it down to 2, so we're not going to see any change here. Right, and I got the case wrong, so hold on, I missed my t. So 2, 2, nothing seems to have changed, right? Well, when I go and I drag this, it's going to adjust that integer value in steps. So you can see it going, oh. So I go 30 feet, I get my 30 feet, I get 33 feet here, turns it into 30 feet here. 30 feet is control turning into 3 times 10 equaling the x integer, the x value. So what this controller allows me to do is just test my formula and see if it is indeed stepping through my formula like that. And I'll show you how that hooks up in the host family in a second. So if I go in here, I can change my step value, 10 feet, to, if I change it to 5 feet, and I'm going to change this to 5 feet also, it just gives me a finer grained control. So you can see that you get steps every 5 feet. Everything's a little tighter. And what this is allowing me to do is it allows me to control what each one of these placements of this family steps. And that's going to be important when I connect it to what its range is. So now just to sort of show you a couple more things here. Now I've also got variables for frequency and amplitude in the translation. And I'm not going to hook those up to anything because those are going to come later. But right now I just want to have something that shows me the relationship between my step and my point number. So I'm going to just undo back a couple steps to before I had my control point. So I'm going to load this into a family to see what we can get for making our sine curve. A new family. I'm going to make an adaptive component. And because this is something that I'm going to want to place in another environment, that's why I'm doing it as an adaptive component. And I'm going to put down basically I'm going to start putting out the scaffolding that I'm going to use to create this thing when I place it. So I'm going to make a reference line with 3D snapping on, like so. And I can just slap this down any old place. And I'll make these two guys adaptive points. And what I'm going to do is I'm going to start placing this family. So I'm going to load it into my family that I just started. And I've got it on my tooltip here. And I'm going to put it on the work plane of this line, because this line is actually going to define the orientation of the sine wave that I'm eventually going to make. So I'm going to do set work plane. I'm going to choose the horizontal work plane of this guy. And I'm just going to start placing this family on it. Now, Revit's going to complain because I'm going to put a bunch of stuff in the same place. But let's see if I can get this right here. So I'm going to go snap end there. And just to make sure that I've got it in the right place, I'm going to select it. I'm just going to go copy, and I'm going to do paste align to same place. It's going to give me that warning. I don't really care. Align to same place. That's 3, 4. Let's do 6 of these. This is going to be a pretty low resolution version, but and so now, because there's a difference in orientation of this reference line versus the environment that I brought it in from, I need to rotate this into place. So I'm going to rotate all of these guys at once. I'm going to put my rotational point right there. And let's see. I was a little screwy about how I did this. There we go. So now I've got my family placed on that line. I can move this thing around and it's going to move with it. Maybe. Hold on. Yeah. So it's moving with it. Now, you'll notice also that I have 6 instances of it placed here. So I'm going to select one of them, and I'm going to change its instance parameter here, the point number, and make this point number 1. And we can see that that one moves to a different place as we set up in the other family. I'm going to set this one to 3. I'm going to set another one to 4, and so on until I get all 6 of them numbered. And you can look at the post that I did on incrementing for a little bit more information on this technique. It's 5. There should be one more guy in here. 6. And just make sure that I've got all of them. Yep, there's only one left. So you can see that it's starting to increment out into these different steps of the sine wave. It's a very low resolution sine wave, but you can see it's there. Now I'm going to make sure that everything is working by I'm just going to make sure that everything's aligned properly here. I'm going to start just making this a little bit more regular looking. So I'm going to put all this stuff back over here and on the origin of this family. So I'm just going to pop these guys over, just using my align tool here, just to sort of neaten up the family a little bit. And you can see that my lines are moving with my reference line, because that's what they're hosted with. So if I take this guy and I stretch it up, everybody moves with it. And this will be important when I put it into my final family that it's going to get hosted into. So now what I need to do now is make a relationship between point 1 and point 2 and my whole sine wave that's going to move through it. So just to sort of show you that this is beginning to make a sine wave, I'm just going to thread these points together a little bit. 1, 2, 3, 4, 5, 6. And you see this is a very rough estimation of my sine wave, but trust me, it really is making a sine wave. And what I need to do is I want point 1 and point 2 to define the range that this whole thing is going to move over. So the first thing I'm going to do is I'm going to just give myself a little bit more workspace here. And I'm going to create a reference line, a reporting parameter, between point 1 and point 2. And I'm going to put it on this line because, as we saw, this line is going to move around, so it wouldn't make sense for me to put a dimension on, basically on level 1. So what I'm going to do is I'm going to make my align dimension, and I'm going to set the work plane, and I'll do it here on the horizontal work plane of this line. And I'm going to make sure that by looking over here at the status bar, that I'm clicking on the adaptive point and on the adaptive point. And from that, I can make a reporting parameter. Add a parameter, and I'm going to call this range. And there's going to be an instance and a reporting parameter. And I need one more piece of information to make sure that all these lines are going to extend all the way out to this point, which is what I want to do to define my range. So in my other family, I had a range parameter, but I'm also going to need a step parameter. That's also going to be an instance. And my step is going to be defined by my range, and it's going to be divided into the number of pieces that I have families. So I have 6 families. So I'm going to take my range and I'm going to divide it into 6 pieces that are each going to be 13 and change each. Now, what that is going to be is I need each one of these things to increment out 13 feet so that it reaches out to the end here. So if I select all of these guys, select all instances, then I've got all of my instance parameters for each one of these families. Now, right now they all have different point numbers, but their step is all the same. And their step is all just set to whatever it was in the family. Now, if I hook that up to my step here, shazam, they all pop right out to the end of this line. And they should persistently do that. If I stretch this guy out, it means that my step changes. So I can just drop this back down to ground level here for a second, just so that it's a little easier to sort of see what's going on. And I can play around with this a little bit and see that if I change this, it's going to change my step, so that these guys are always going to add up to the end of this line, to the range. Now similarly, I also had an amplitude parameter, which I'd also like to have, because that way I can go click 1 to start the line, click 2 to end the range of it, but I'd also like to be able to control my amplitude. So I'm going to add another point, and just to make this a little easier to set up, I'm going to put it on this vertical work plane. And this is going to be another adaptive point, like so. And I'm just going to align it so that it is a little easier to deal with. And just as I did before, I'm going to take those points and I'm going to thread them together. This time I'm just going to do a spline by points and make it a reference line. And I'm going to put another reporting parameter on here. another line dimension where I set the work plane, and I'll tab into this guy. Adaptive point to adaptive point. Select it, add a parameter, and this one's going to be called amplitude. It's going to be an instance and a reporting parameter. Now again, if I select all of these guys in the entire project, see that I've got an amplitude parameter. And if I hook that up to my amplitude parameter here, suddenly I've got a controller that can nicely manipulate what the amplitude of this sine wave is. And so what it's doing is it's taking the same formula that is being used back over in this guy, see this one right here, and it's just manipulating different variables within it, but it's manipulating it for all of them in this family. So now I'm ready to do some basic sort of testing, make sure that this thing is working how I want it to in a host environment. So I'm going to go new project. Oops, sorry, I don't want a project. I could do it in a project, but I want to do a new mass family right there. And I'm going to take my brand spanking new family here, which is an adaptive component. I'm going to load it into family 6. And see, I've got it right there on my tooltip. And right now I'm placing it on level 1. So I'm just going to go place 0.1, 0.2, and 0.3 is going to be a little funny. Let me set that on a work plane over here so that it's vertical. So let's see how we did. We've got our 3 points. I can tab into 0.2, or actually just can select it, and I can stretch it out. And we see that my range is increasing and decreasing depending on how I slide around 0.2. I can take 0.3 and I can increase the range. And again, this is a really low resolution version of this sine wave. In the other family that I had, there are 20 loaded lines. Now, if I go back and just to sort of show you, so this has 20 instances of that family loaded, and it just makes for not so good television to watch placing 20 instances of these. But you get the idea, I hope, with just these 6 placed instances that you can start to define your sine wave. So I've still got a couple of things left in here. I've got, I'm going to select all of these guys again. And I've got a couple of unassigned parameters here. I've got my frequency and I've got my translation. Frequency is, how many oscillations it makes between 0.1 and 0.2. So I can hook that up to something else too. I can add a new parameter that is frequency, and I'll make that an instance parameter too, although, well, let's make it a type just to sort of show you that you can. And I'm going to also add a translation, and let's make that a type parameter too. And that is going to be translation. And what this will allow me to do now is that if I load this back into my project, family 6, over at the parameter values, now I've got a family that if I select it, I can edit the type parameters and see here I've got my frequency and I've got my translation. Sorry, it's a little weird how I've organized it. But if I change my frequency here to, say, let's make it a really long waveform, I can apply that and I can see it percolate down into this guy. And I can change the translation, which is how it moves, where the beginning of that sine wave is. Let's make it 20 feet. I don't know where that's going to go. And so I can manipulate this curve on all sorts of different levels. I'm just going to undo that so it looks more wavy again. And basically you can sort of make your changes on based on how you're going to need to use a line like this. If it makes sense for you to host it on things, then you're going to want to have adaptive points. If you're going to want to change things numerically, you would probably want to keep your things in type or instance parameters. And then finally, you can just go back in and start cleaning this guy back up. So I took all of these guys in the family that I'm posting on online, and I took all of them and I turned off the visibility of those lines. So if I load this back into this family, all you have is just the curve like that. And then you can use this for whatever you want, whether that's to host some geometry on like this, and then you can use it to create form elements. So I'm just going to do a little tube along it like this. Let's see. And then this form element is still going to be associated with the geometry that I've put it on. So if I take that guy and I'm going to change the range on it again by moving my point 2, all my hosted geometry is going to go along with it. And if you want to sort of have more access to those points, you can go in and you can select points 1, 2, and 3, and you can change the visibility settings of them here in the properties again. So that'll just mean that they'll be visible in their host. And these are all just sort of matters of personal preference about what you want to have visible and what you want to have access to. So now I can just sort of see that right there and grab it. Makes it a little bit more convenient. So these examples will be posted, and you can dissect these families and see what else I might have missed in the descriptions. And I hope you can have some fun with these guys.